right, so this is a talk, a pretty technical talk. I don't have any slides. Are you guys okay with that? There are people that really like PowerPoint. So I tend to piss them off with this. So we're going to talk about 12-factor apps and also using all this container stuff that people have been talking about lately and how I think it adds a few things that are not described in 12-factor. So how many people are familiar with the 12-factor manifesto? All right, fantastic. So the rest of you, you should really go find these people at lunch because I think this 12-factor pattern is starting to become more and more of a requirement as most people are moving to more robust infrastructures that are not necessarily managed with scripts, right? So we're moving into a world now when you write an app, you should be able to deploy it anywhere, whether that's Heroku, a virtual machine, or some distributed system that's managed by a scheduler. How many people here have ever used a scheduler before? Man, this is going to be new for a lot of you all. So I'm going to describe a little bit about what a scheduler is before we jump into 12-factor. So now that you're having your app, we're getting really close to this world of utility computing where you can take your app and run it anywhere. But that also means you're not going to necessarily be able to target a single host, right? Like this host name is named My Little Pony, and My Little Pony runs the database, right? That world is gone. You're just going to run your workloads, and there's going to be a scheduler that picks it up and runs it somewhere. The whole goal of this is to be super efficient. All right, so how many people have like one-click deployment scripts, right? This was the holy grail years ago, right? That's when you're badass, right? You like run a script and you deploy it everywhere, right? Awesome. There's a problem with that though. It doesn't take into resource considerations. You spin up a VM, you run your scripts, and you don't know if you're using all the resources or not. It's pretty wasteful. So I'm going to try to articulate that in a way that I think will have some good visual aid. So I do that normally with a game called Tetris. How many people have played Tetris? And the rest of you had some really bad childhoods. All right, so I'm going to show you what it's like to have one-click deployments, right? So you have all your workloads, and they're different shapes and sizes. So your scripts run pretty fast, so it's like level 9 here, okay? So what you do is you kind of click that button, one-click deploy, and you walk away. And this is what your scripts are pretty much doing to your infrastructure resources. You saw that stuff on the left and right? That's CPU and memory going in the trash, okay? So I work at a cloud provider, and this does wonders for our stock options. So we're going to do a little better. So what we want to do now is take a lot of that automation and roll it into the system. So what we want to do is use a scheduler and let the scheduler be a little bit smarter about where it's placing our workloads, right? So things will still be automated and fully managed, but what we want to do is have something that's intelligently looking at every workload and deciding what server it should run on, okay? So let's start here. So our scheduler will look at the workload and do what we call bin packing, okay? So the idea here is not to automatically spread our load on every server. It's to really look at the workloads that are coming and put them in the right place, leaving room for the right pieces to fit. Now, we do this. Look at you guys like, he's going to make a mistake. I will recover if I do. That was by design. So what these schedulers usually do is fill in all the gaps, utilizing our resources across the cluster. And what we want to do is do this and reserve room until the right piece shows up. And the right piece can take a long time. And when you get it just right, and that big workload shows up, your scheduler knows where to put it, okay? That was awesome. You should totally clap. Now, there's a bit of a challenge here. A lot of people work at not a startup, right? These are the companies that like make money, okay? You ever heard of these companies? So if you were at a company that actually has real applications, you have a bit of a challenge, right? If you've been following the fads for the last 10 years, your infrastructure is not so pretty, okay? Some people call it legacy. So in that world, you're not necessarily starting off in the right place, okay? So you may be writing Java. Nothing's really bad with Java, but it's kind of not the best language to write in my opinion. Worse if you're using Oracle. Anyone have the support of Oracle database? You can just nod a little bit. That's you. That's okay. You don't have to show your thing. Okay, so if you have all of those things, your infrastructure looks like this. And the stuff that I'm going to show you today can't help you. So unfortunately, this won't work for you. But keep hope alive. One day, you can definitely switch jobs. All right. All right, so now we're going to get into what's required to do this 12-factor thing, okay? So this 12-factor thing actually is a lot of good practices, right? I don't necessarily say they're the best practices, but there are a lot of good practices that make your workload super portable. So in order for these schedulers to be effective, we have to have some conventions and some constraints. One of them is I do not want any deployment scripts, right? I don't care if you're writing Ruby, Python, or Node.js. Doesn't matter. We want to simplify things so that way we can automate and focus on the workload, not the language underneath. So this would be very similar to what you do at FedEx, right? When you go to FedEx, you put it in a box. Whatever you're putting in the box, it could be drugs, it can be things that are legal, doesn't matter. They put a label on it and they ship it, okay? Now, if you get in trouble for the thing that you're shipping, well, that's on you, right? That's like DevOps, right? We ship it, it breaks, we all wake up together, okay? So this is what we want. So this is where containers come in, right? So containers really give people this way to start communicating with this contract. Don't tell me about the app, put it in the box, and we ship it. So once we have this thing in the box, we can start to do things. So let's go through the 12-factor thing a little bit here. So code base, right? Hopefully you have version control, right? This is a GitHub conference. If you don't know what version control is, you have a problem. So my app is stored in GitHub. I only have 12 stars? What the hell? All right. 13. Is it okay to like start your own projects? Hell yeah. All of them? Right, they look pretty popular. Like all your repositories have like 1 star. You got to motivate others, right? Like lead by example. I get you. Okay. All right, so in this 12-factor world, so we want to have our stuff in the source code. So this is like obvious. But honestly, before this was like written, a lot of people just thought that they can just wing it. You know, my laptop will never crash, and they had all the source code there. It's great for job security. Like, you will be the last person fired. You have the source code, okay? So dependencies. This one's a weird one. Like, I think containers take this particular factor to the next level. So when this was written, a lot of people were writing Ruby. Any Ruby on Rails people here? Ruby? Make noise if you like Ruby. All right. What about the Node.js folks? So those are the people responsible for clogging the internet. npm install, you're like, whoa, I didn't know that much data was on the internet. So what containers do is they take all of that and truly let you bring in your dependencies next to your app. So npm and Ruby gems, those are great package managers. They allow you to really express yourself in terms of dependencies and bundle them in a way where there's at least a dependencies file that people can install your app and all its dependencies. But containers take this one more level where we can just say, let's just install all of our dependencies and put it in that package we ship around. So we take care of that particular factor with containers. Now config, this is a touchy one to me. So in this config factor, and you can click on all of these on the website, in the config factor, ideally we should not deal with config files, okay? And the reason for that is if you're dealing with like a virtual machine and you're asking people to copy around config files from server to server, that can be quite tedious. And also you're gonna get into a situation where we're gonna start skewing your config. So this suggestion is that you should use environment variables. And how many people have tried to configure their app solely by environment variables? This is a terrible thing, isn't it? What about a TLS certificate? You stick that in an environment variable? Doesn't work out so well. So I think this one can be adjusted a little bit, and we can start thinking about the environment you're running in can be dynamic. We can actually read files, and they don't have to be on a traditional file system. TempFS works. I'm going to show how Kubernetes can help with that. Some of these other things are just common sense, like if you're building your app in production, that's a problem. So you should probably separate those steps. So containers really help with that, right? You build your app, all of its dependencies, you push it to a repository, and then you can run it at some other date. This is common sense stuff. This whole stateless thing, right? I think this is a good pattern if you can try to isolate state where it belongs. You know, don't have every single app trying to be responsible for all of its data, meaning you can't move it around. You want to keep these things a little bit more portable. This port binding thing, I take issue with as well. I think that was a limitation of when this thing was written, right? So the suggestion was you should be giving your port when your application starts. I think that was too platform specific. If you're dealing with a platform that can't give you an IP address per process, then this will be something you need to do. But the world has changed a little bit, so we're going to show that a little bit as well. And then this other big one that I'm going to focus on today is dev prod parity. Okay, your laptop is not production. Okay, it's not even close to production. So we want to look at a way, how can we get something that's very similar in two environments that lets us reuse our deployment methods. So what we're going to do is jump into an application. So the code-wise, this is, how many developers here? So I'm a sysadmin, and developers piss off sysadmins. You know why? How many people have an app when you start it and the database isn't there and the app crashes? Every sysadmin is like, why the hell don't you retry the database? Right? I'm going to bring it up. If I don't bring up the database, we're going to go out of business. So I promise you the database will be brought up. So I'm going to give you guys a little bit of code to show what I think the startup process should look like if you want to be helpful to people in your organization. The first one is so simple. You see this line right here? I'm going to make it a little bigger. Let's see if we can zoom this in a little bit. This first line is important. You see that? What is that? It's a log message. It says your app is starting. Sysadmins deploy your app and nothing happens. We don't know if it's broken. We got to jump on the box and look at the process table. Just log, hey, I'm starting. Right? That's the positive feedback. I mean, simple thing. If you don't have this in your app, when you leave lunch, go and do a pull request and add the damn log line, okay? This is going to help everybody. The next thing you need to do, seriously, is shut down cleanly, okay? Your app will probably get shut down at some point, right, between now and the end of time. Your job is to shut down cleanly, okay? How many people know how to shut down cleanly? It's like 5 or 6 people. So there's this thing called Unix. And when you get shut down, you're going to give a signal. Hey, sig term, it's time to exit. Most people say, all right, whatever. And they just sit there. And if you're using a bad process manager, it's going to sit there forever. Some of them will just kill your app. You're like, yeah, that's fine. Is it? What about those open database connections, right? MongoDB for the longest time would just say, hey, we'll keep them around. MongoDB stops. That's called outage, okay? And that's a very painful retrospective to be in, right? It's a lot of finger pointing. You shouldn't blame people in retrospectives. I do, right? It was the developer's fault. They don't do clean shutdowns, right? So this is the thing that you should try to do in all of your apps. Shut down cleanly, handle signals, and process the last few HTTP requests on the way down, right? So this code's on GitHub, so you guys can check it out. So now let's deploy this app, right? So we have this app in a container. So let's say we're working together. Okay, and you say, how do I get this application in Kubernetes, right? So the first thing you need to do is to have a container, right? And once we have a container, we push it to a Docker Hub or some other container registry, and then we need to describe this app. So no more scripts, no more Capistrano, no more bash scripts. We want a declarative system, and this is what Kubernetes gives for us. So we have an automated platform that we just declare what we want. So here we're going to declare our Hello World app. So the thing that we're doing now is a Hello World app, and there's an authentication service, and there's going to be a front end, right? So the one thing I want to do is make sure that I can expose this front end to the world. So I have a couple of services here. One is going to be my front end service. Very simple declaration here. I give this to Kubernetes. It's going to create a front end load balancer for me, right? So in my cloud provider of choice, I submit this to the cluster, and a bunch of things will happen in the background. And they're going to create a load balancer for me. So I'm going to go ahead and create a bunch of services now. Now, Kubernetes also has built-in service discovery. So in Kubernetes, every workload that we run, you're going to get your own IP address. So you don't have to deal with port mappings. You can pick whatever port you want, and you don't have to worry about clashing with any other service. So I'm going to create a bunch of services really quick. So let's make sure that we're in the right environment. So one thing I'm going to do is figure out where I am. So let's see, current context. All right, so I'm in the testing environment, okay? So let's go ahead and create all of this stuff in this environment. So what we're going to do is create some services. So here's my front-end service. And I'm also going to do it for my auth and my hello service. So I'm going to go ahead and create those now. So behind the scenes, Kubernetes is going to interact with my cloud provider of choice and also going to give me internal DNS so that I can reach all of these services. So you don't have to try to worry about figuring out service discovery. All right, so all those things are in place, and I can go and see what services are available by looking in Kubernetes. All right, great. So I see that my public IP address is pending for my front end, and I see that I have cluster IPs for my auth and hello service. So we're in good shape now. So the next thing that I want to do is, actually for my front end, we need a few things. Now, we need some security. So we're going to use HTTPS for our front end. Now, how many people have experience with like Docker at all? Okay. Now, in the Docker world, it looks so easy, right? You just run your app, everything is good. But where do you put your configuration files? Has anyone figured that out? The suggestion has been build a new container with the config file in it. That's equivalent to checking in passwords into GitHub. How many people have ever done that? Like you just like, oh shit, that's the database password. How many GitHub employees are here? I want you guys laugh your ass off when you get that email. Could you like delete all the data in my repository? So you don't want to be packaging configs with your containers. There's a better way. So in Kubernetes, we have what we call secrets and config maps. So these are separate objects that allow us to create objects in Kubernetes that hold of our configuration data and our secrets. And then we can refer to them when we deploy our app. So down here I'm saying, I don't use environment variables for Nginx. Nginx doesn't understand environment variables for config. So I need to actually have these things somewhere on a file system. Now, there's no need to write them to a local file system on the host. That's not important. Only the application needs to see these configs and secrets. So we can use a tempfs, right? So a file system that only lives in memory, and then we'll inject it into the running application. So let's do that now. So let's create these secrets. Let's say kubectl create, let's say start with the config map. And we're going to create a config map named nginx frontend conf, okay? And then we're going to say from file, and then we're going to just take this nginx configuration file that I have on disk. So this is for my front end, okay? So we create that, and now that lives inside of Kubernetes. Let's go ahead and create the secret really quick. So we have this secret. I'm going to make it a generic secret. We have different kinds of secret in Kubernetes, but this is a generic one. And here I want to store my SSL certs. So I'm just going to call this one TLS certs. And then I'm also going to give it a directory of certs. All right, so this will be TLS. What did I do wrong? Secrets doesn't need an S. All right, so now I have a bunch of secrets and my configuration files. All right, so these things are now sitting there ready to be referenced by my application. So now let's deploy my front end. So kubectl, remember all of this is declarative. So we deploy our front end app, and then let's go ahead and make sure that that's running. So in Kubernetes, we create what we call pods for all of our containers. So we can run one or more containers in what we call a pod. So this would be a logical construct that works a little bit like a VM. Ideally, wow, this is cutting in and out. So ideally, if you need to have tight coupled dependencies, maybe using Nginx as your front end for rate limiting, and your app is written in like Ruby on Rails or something, you can deploy those two things together, and they live in the same context. So now we have our front end ready. And now that that's running, we can go ahead and launch our other services. So let's go ahead and create deployments, our auth service. And we'll also go ahead and create the hello service, okay? So these are all declarative, and we're declaring that this particular namespace needs to run all of these things, all right? So once this is running, we should be able to hit the front-end web service on its public IP. Okay? So now we have this public IP address. Ideally, this is HTTPS. It has all our certs in place. Now, these are self-signed certs. So let's see if this works. So we'll put HTTPS here. Please work. There are people watching. It works. You see the little X there? Like if you're logged into your bank and you see that, you probably shouldn't complete the process, okay? A lot of people don't know that. So yes, now our app is working. Let's go ahead and look at the version. So we did all of this in testing, all right? So we're going through our front end. We see the right version. And one thing we can also do is make sure the login service works. So great, everything working. So that was in testing. Now what's the reason of having all of this in a declarative format, right? You notice there's no scripts here. So what happens if we switch to production and we want to do the same thing? We want parity in the way that we work. So what I'll do now is we'll switch to, let's switch to our production part of the cluster. So what we'll do is now say Kubernetes can actually manage multiple clusters, and we encourage people to do so. So we want to switch our context now. So let's say use context. So we're going to use context, and we're going to switch to production. All right, so now that we're in production, if I list things here, all right, we'll see that there's nothing there. Come on, internet, great. So now all we need to do is go through the same steps. So let's create our secret really quick. So we create our TLS certs, okay? Ideally, you should have different certs for the two environments, but this is a wildcard, so it works. And then we'll create our config map. And I'm doing all of this in the context of this particular cluster. So this is my production cluster. And then we'll create all the services. We have a front-end service. And all these things should be checked in your repository. And normally CI could actually run through this process for you. So you can almost treat these configs like code in a way. Anyone wants to do a change to them? Uh-oh, TLS handshake timeout. Whoo, come on, AT&T. So I'm tethering to my phone down here. And all right, good. We're making progress. So we'll do hello. And then we need our off service, okay? So those will spin up a separate load balancer because we're in production now. And then we'll go ahead and spin up our services. All right, so create -f, deployments, front end. And then we'll do auth and health, or auth and hello. And we'll see if it works. And even though I'm typing these one by one, it's just so that you can follow along, but I could just say create -f and give it all those directories, and it will do the same thing. So I say get pods now. Let's see if everything's running. So some things are on the way up. Containers are being downloaded. So now we're up and running. So let's see what the new production IP address is. All right, so it's still pending. Now, one thing you will want to do is if you ever have to troubleshoot these things, let's say Nginx is having issues and you really want to log in. So we don't really care what servers these are running on. Remember, our scheduler is picking the right place to run these particular workloads. But if you really need to, as one must do in production sometimes, you can log into these things. All right, so this is a running container. So we can log into our running Nginx thing. So exec into this thing. Let's get a shell. It's very exhilarating to log into production as a developer. It's like, I'm in production. What can I do here? Okay. So now we're in our production container, and the nice thing about this is we go through our API server, and it finds wherever this pod is running, right? So if you need to log in to troubleshoot, you totally can. The other thing that you can do is you can get logs remotely. So you can say kubectl logs and grab, let's say, your Nginx front end. Let's see if it's actually working. We have no logs yet, so let's see if our service is ready. All right, so we have our front end. Chances of this working? Oh, HTTPS, the guy in the audience is like, he doesn't get it. I do. All right? So when you see this, this is fine. This is harmless. Just go ahead and proceed. So we're working now. And a nice thing, I didn't have to change my workflow between testing and production. All right? So you look at this as like, dude, those are apps you wrote. That's super easy, right? They're written in Golang. There's these little static binaries. Of course it works. Let's up the challenge. Say you got a startup now. You saw all this, and it's a Ruby app, okay? Ruby is one of the hardest things to package and build for. So I go to GitHub, and I find this project called Lobsters. Lobsters is a GitHub clone, or not a GitHub clone. It's a Hacker News clone. How many people visit Hacker News? You should do it at work. Like the first thing you do when you get in, you visit Hacker News, and you have the best stand-up conversation. What did you do yesterday? Nothing, but man, did you know Microsoft is about to buy Docker? Rumors. All right, so we have this Hacker News clone. So this is a typical Rails app. So now comes the hard part. I want to run my database in this thing. Can you do that? Like, yeah, I can do that. So the first thing we need is a disk. All right, so let's go ahead and create a volume. So in Kubernetes, we need network attached volumes. And why do we need that? We don't want to depend on the local machine for anything. So we want is a network attached storage that we can use to compose and move our app around and also reattach the storage where we need it. So what we're going to do now is make sure that we have a disk and list. And I just want to make sure I have this MySQL data disk. And I don't see it, so let's create one. All right, so we'll create a volume. So this disk, we'll be able to refer to it later, right? So once we have this disk, we can deploy MySQL. So what does it look like to deploy MySQL in one of these things? Very similar to what we saw for a normal app. We pull down the container. One thing we can also do is we can use environment variables for this container. It has a wrapper script in it, and we can store our secrets inside of Kubernetes itself. So we'll do that so we don't have to leak any of this stuff. And then we'll refer to the disk that we want to use and mount it inside of our running container. So this will be a normal volume. All right, so once we have that in place, we can go ahead and create our database. All right, so here we go. I also want to create a service for this so that other apps can find my database using DNS. So we create our MySQL service. So that's now up and running. And let's go ahead and create our database now. So we'll do this. And what will happen at this point is Kubernetes is going to look at our description. Oh, we need secrets. So this is going to fail, but it's pretty easy to stop the show. Let's go ahead and create our secrets really quick. Yes. All right, so let's go ahead and create some secrets. So we need a couple of secrets here. I want to set the username and password for this Lobsters app, and I also want to give this Ruby on Rails app a connection string so that it can use to connect to our database. So I'll go ahead and pop in these two secrets. And remember, all this is declarative, so what's happening is I'm storing these inside of Kubernetes to be referred to later. So we're not really running any scripts here, just declaring these things. All right, so now they're up and running. So once we have those, we can go ahead and create that deployment now. So what this will do is schedule MySQL onto one of our running servers, and then it will attach that disk, refer to the secrets, and initialize our database, all right? And then we should be almost ready to go. So let's list this and see what happens. All right, so we see that MySQL container is now creating. And this will take a few seconds as we attach the disk. And while we're doing that, let's go ahead and create the service for our Lobsters app. Again, we want a front-end load balancer here. So we'll have a front end for Lobsters. And let's check on that database. All right, so now we have this MySQL database running. And when I do this review, it's like, that's not real. You can't connect to it. So one thing we can do is we can actually do a port forward command and actually connect to this without exposing it to the public internet. We'll just do it over 3306 to show people this is a real MySQL instance running. Don't fake the demos. I've seen people do that. I was like, dude, you didn't do anything. That was a video. All right, so let's do MySQL. So now that I have this running on a port forward, I can do host equals localhost. And then I'll just do user will be Lobsters. Okay, so now we're connected to our running database out in our Kubernetes cluster. So good, we're ready. So now let's go ahead and get the app going. Again, it's declarative. So we can say deployments, Lobsters, and it's very similar, except for I'm going to grab my secret from the Kubernetes secret store and give that to the application. So this is a standard Rails convention. All I did was package up this app from GitHub following the instructions and created a container for it. So now I can feed it its configuration from Kubernetes. So now let's go ahead and create this deployment. -F. All right, so if this all works, this thing should come up, find MySQL, and connect. All right, so let's get our service. kubectl, get pods. All right, so here's Lobsters. It says it's running. Let's get its public IP. All right, so let's grab this public IP. Let's see what happens. It's Rails. What do you expect? So this is where it gets hard. Not everything is an app that's packaged and ready to go. So you have to run migration scripts with this app, right? So we should be able to support that. So Kubernetes also has what we call jobs. And these are one-time execution. Now, have any of you ever did like a database migration before? I've seen people just get on a random server and run the migration and take the database and the app server down. So in our case, we want to actually use the scheduler to place our one-time run workload and run the script until it exits. and then babysit it to make sure that it executes correctly. So what we're going to do now is use a job. So say jobs, and then what we want to do is fix the schema. So this is just a typical Rails migration. So I'm going to use the same container that I'm using to run my app. I'm also going to use the same secret to get the connection string. And then down here, I'm going to specify the rate command that I want to use, okay? And I'm going to let Kubernetes decide where's the best server to run this on and make sure that it exits 0 for me, okay? So I'm just going to declare that this job should be running. So -f, jobs, and we're going to run our schema migration. So this will run as a job. It will run one time until it exits. So it'll take a few seconds. All right, so it should be done. All right, so that works. So now we've put the database schema in place. So the next thing you need to do is log in to create some content. So we'll try to log in as a test user, but I know I'm going to need to seed that data. So I'll run one more job. We'll run our database seed job, okay? So once we have this job running, we should have our test credentials in place. I'll give it a few seconds to run. And Kubernetes keeps an audit log of everything that it's doing. So if you ever have to troubleshoot who did what, it's all in there. So with this seed job in place, I should be able to log into the server or into the service, okay? So we're here now. Now that you have your startup and you have your app deployed, you need data and users. Anyone have heard of growth hacking? Oh, it's a great strategy. So what you do is you go to your competitor site. You need content. And don't waste time curating the content. So what you do is you submit stories. We could write a script to do this, but let's keep it somewhat ethical. You do this thing like borrowing content, okay? Otherwise known as copying and pasting. So what you do is you just kind of grab the highest rated stories. We'll do this. This is totally legit. And I am the author of this story, and you're, yeah. Hit submit. Like, bam, it's working. Now, the cool thing about Kubernetes, so that's pretty straightforward. So we have all of our stuff running now. You're getting pretty popular. So what happens if we delete the database? So let's grab this MySQL instance and delete it. Now, normally what happens here is you have a service call someone around 2:30, 3 a.m. in the middle of the night. They wake up, they read the alerts, and they try to get the database up and running as quickly as possible, right? So depending on what's going on, users may see weird things, so this is going to hang for a while. And what Kubernetes will do behind the scenes for us is know that we've declared that we want MySQL always running. So it's going to pick up where it left off, take that network attached volume, schedule it to a new node, because that node may have died or maybe someone deleted it, but no one changed the requirement that it needs to be running. So what it will do is recreate our database, and we're back where we left off, okay? So now our data store should be in good shape. Let's see, we don't want this. It should be back in good shape. Let's make sure. This is Rails, by the way, so let's scale this up a little bit. So this thing may have issues with connecting to the database again. So let's go ahead and scale it really quick to get more instances. So scale, we want to scale our deployment for lobsters, and we'll scale to how many? Throw a number out there. 38? This is when you debate, do you go for the broken demo or what you know will work? We're going to go 38. This is not a good idea at all. Let's see what happens. So what Kubernetes will do is try to create as many of these that you have resources for. All right? Oh, snap. Oh, they're all running. That's pretty badass. Okay, let's see if this thing actually pulls up our site now. Bam. All right, so the last thing is you're starting to get popular, and you hire a marketing team. The marketing is like, ugh, this is just so plain. All I see is an empty canvas here. So they go to work, and they get your developers to spend their quality time making an update, okay? So now it's time to deploy that update. And that container is now ready. I'm a sysadmin, I don't care what you guys deploy, so you tell me the version number, that's what we're gonna do, okay? So we're gonna deploy this thing, and I'm just going to apply. So ideally, I would check this into like GitHub and do a pull request, and now I'm going to apply the changes. So we're going to roll out a new version of the app. So what's going to happen behind the scenes, I've told Kubernetes that the cluster should have a specific version running, and the current version doesn't match that state. Now, what should happen is Kubernetes should go find all of those instances and do a rolling update of them in a way that doesn't drop traffic. And this is why it's so important that you handle the shutdown cleanly, because tools like this will assume that you can handle that last set of applications that are connecting in. Let's do git pods. So what the hell? Oh, I know why this happened. The declaration that I have on the file system says 1 instead of that. What was that number? 38? Okay, we'll hold true. It's not a good idea, I know. All right, so we'll do that again. And then we should get maybe 38 of these things at some point. Wow, there's 38 now. Let's see. So marketing is like, is it done yet? And you're like, yeah. So that's Kubernetes. Thank you all. Any questions? I don't know if we have time for them. Oh, yeah, we have like 4 or 5 minutes. Great. So the question was, can I explain the differences between the networking between the containers, the host, and the external IPs? So a system like this, kind of very similar to the system we run at Google, we assume that each cluster has what we call a flat network, right? So that means every container, every pod, has its own IP address, and it can talk to every other container or pod in the network, okay? In this case, the containers are your first-class citizen, and they become the thing that we talk to directly. So the host is just there to give us CPU and memory, but they're not the thing that we target at any point, okay? So the hosts do have their own IP addresses, but what we do is use a different set of what we call subnets across all the machines. You should be used to this if you use any cloud provider, right? They're running a hypervisor underneath you, and they give you VMs that have their own IP address that's different from the host. So if you're used to virtualization or using VMs at all, you're already using this pattern, except for now we're doing this at the container level. So most people choose to do this on bare metal. You can also do this on top of a VM. In terms of the public interface, it's very similar to the model you see in the cloud. When I'm creating that public load balancer, that's going out to my cloud provider, creating that load balancer, giving me an IP address, and then that just routes into the containers inside the cluster. So flat network, 3 layers of IP, public, cluster level, and then the host level. And you avoid using the host level for anything if you can help it. Okay, good question. Cool, so there's a couple questions there. One of them was, how does this compare in terms of cost to other cloud providers, all right? So Kubernetes is an open source project. You can run it in any cloud provider that you choose, okay? So you would have to make a distinction. Do I want to run this on bare metal because that's what I'm doing? Do you want to run this on Amazon? Do you want to run it on Google's cloud? You choose, okay? You just need VMs, and Kubernetes sits on top of that. Now, what Kubernetes is supposed to do is like what I showed you with the Tetris game. The idea is to get your resource utilization up. If you think about the current pattern that most people are doing with VMs, you have 1 app per VM, right? And you throw that in an auto-scaling group. And you're just wasting CPU and memory. It's pretty terrible, right? And then you have another copy of the OS in every VM that you're running. So it's going to cost you 256 megs of RAM that you're just paying for because you want that isolation. So now that we have that isolation with containers, we put Kubernetes on top of that compute. Then we get a little bit smarter about how we carve that up. So now you can probably go from 100 little small servers to, let's say, 35 slightly bigger servers, but still less in cost than the aggregate of the smaller ones you were using, and let Kubernetes play Tetris and schedule those workloads and plug in and get better utilization. So we see this from people that have run this and running this in production. This pattern works really well, especially if you're in that 12-factor sweet spot, okay? And your other question, I totally forgot it, so you got to remind me really quick. Yeah, so one thing you should notice, Kubernetes itself is a lot like a Linux kernel, right? It's very low level. It's high level enough where you can build a CI system from it, and a lot of people are doing this. But really, the API is so extensive. Everything that I've been doing on the command line actually has a one-to-one command line equivalent. If you want to know what that API looks like, we have some docs on that. But if you just run like verbose 9, we actually translate all those commands into curl commands. So you can actually see how to interact with the API and the results that come back. That's a lot of data from 38 containers. Thank you for that. So you see the curl commands, or they were up there. So it basically just shows you, so it's an API. So if you want auto-scaling, we do have an object called horizontal autoscaler that you can give it some lows and highs based on CPU metrics. But we're seeing a lot of people do, since it is an API, they can go and monitor any external resource, whether it's a New Relic metric, and then choose to scale up and down based on that. All right? I think there's one more question here in the front. Yep. All right, so you're saying you have a bunch of nodes, so kubectl get nodes, right? And these are our nodes, and we say kubectl get pods option wide, okay? And then we have all this stuff running on those nodes, okay? So if we take one of these nodes here, right? So that node, and if we were, I'm going to try to do something a little quicker. There's a drain command that will simulate like this failing, or just saying I want to go into like drain mode. So I can drain one of our nodes. We're just going to force it to put it in a bad state. Okay? So if you were to pull the plug on this machine or drain it like I'm doing now, what will happen is, oh, so this one's saying, hey, you have this one that has some local storage going down. I don't care. Let's override all of that. Okay? So what's going to happen now is this node is now dead. We're forcibly kicking it out of the cluster. And it's telling me now that these are all the things that were running there. And Kubernetes is going to spring into action and place them somewhere else, right? Because in our declaration, we never said it runs on this server. We said it just has to run. So Kubernetes finds a new home. So now you may have a blip because things were trying to talk to it. This is why you want to have more than one copy if you can help it. But what happens now, we do get pods. Maybe they're going to come back too fast. But you'll see that some of these now have been running for 29 seconds. So anything running has to have a home, and we have more capacity in the cluster. So those things just get recreated wherever the resources are. So this is a distributed system that's meant for things to fail, right? We know it's going to fail, so we don't assume things will stay up. So given that, the right thing to do is just to take that declaration and just run them somewhere else, okay? So this is exactly what happens when a node goes down, all right? I think I'm over time now. I don't want to hold you guys from the break. Thank you all so much.